This example is telling us that the mean value theorem guarantees the existence of what they call a special point on the graph of f of x on the interval x equals 0 to 4. And they want to know in this problem specifically, what are the coordinates of that special point that's guaranteed right there. So at this point in the process, you either know the mean value theorem or you're saying to yourself, what the heck is the mean value theorem? Well, you got to know what the mean value theorem is. The mean value theorem it states if f of x, if your equation is continuous on a closed interval from a to b and differentiable, it's got to be both of these things, differentiable on the open interval a to b, that's an x interval, then you're guaranteed this special point. Then you're guaranteed, then there is a c value in the interval that you've got there, such that this special thing happens, such that f of b minus f of a all over b minus a, your average rate of change between your endpoints is going to equal your derivative at that c value. So your instantaneous rate of change. If we look at that in terms of a graph, a quick example, say something that looks like this. So what it's saying is, I have this graph starting at A, there's this value. Starting at B, there's this value. My average rate of change between those two, so the line connecting those two dots, that's our average rate of change. That slope is equal to the instantaneous rate of change at some value in between. So maybe it's like right here. You've got this instantaneous rate of change. That slope of that line, they're the same. That's a horrible drawing on my part, but you get what I'm saying. Like these two lines would have the same slope. It can happen at multiple places. You could have another place where the tangent line is the same. But you are guaranteed at least one c value that lives in your interval AB. So to do this, you come through, the process is pretty straightforward. Usually on a mean value theorem, step one of the process is they want you to acknowledge that your if portion is true. So for this, you would say, my function, f of x equals the square root of x, is continuous on that x interval, 0 to 4, and it is differentiable on the open interval, 0 to 4. So because we've filled that piece out, we now get to apply the mean value theorem. And so to do the mean value theorem, the first thing you're going to want to do is you're going to want to find that average rate of change. We need to go find that average rate of change between our two endpoints. So we go find the average rate of change. We've got an x value of 0 and we've got an x value of 4. That's my A and that's my B, right? We need the y values off of there because we're just really doing a slope setup. So we would do f of 0 equals, plugging 0 into our equation they gave us, we get the square root of 0 equals 0. And then plugging in 4, f of 4, we get the square root of 4 is equal to 2. So what we know right now is we have the point 0, 0, and we have the point 4, 2. And to find our average rate of change, we're just going to do this equation here, which is just a fancy way of saying y2 minus y1 over x2 minus x1. So x1, y1, x2, y2. Put the pieces in the right place. So y2 minus y1 over x2 minus x1. So we get 2 over 4, which equals 1/2. So that is our average rate of change. So right now we know that our average rate of change is 1/2. The mean value theorem guarantees us that somewhere our instantaneous rate of change is also equal to 1/2. We know that our instantaneous rate of change at some place has to be equal to 1/2. And so we just need to find out where is that. So we take our equation, square root of x, and we find the derivative. Instantaneous rate of change is the derivative equation. So first and foremost, we see a root in the problem. So before we can just rush in to take our derivative, we always need to do a rewrite on that. This is our power over root rewrite. So anytime you've got a root in a problem, x to some power inside a root, you need to always rewrite that as x to the power divided by the root. So here we've got a power of 1 and a root of 2, so that is x to the 1/2. Now we take our derivative. That's just going to be a straight up power rule derivative. So f prime of x is going to equal, bring the power down, so 1/2 x subtract 1 from the power gets us x to the negative 1/2. So that is our derivative. That's our instantaneous rate of change as well. And so we know that has to equal 1/2. So then from there, what you're going to do for step 3 is you're just going to take those two bits of information, set them equal to each other, and find your x value. So you know your average rate of change, 1/2, has to equal your instantaneous rate of change. And that where that happens, that's our magic C value that's going to live somewhere between 0 and 4. So we do a little bit of algebra to solve for x here. We're going to start by isolating the x. So to cancel out the 1/2, we're going to multiply both sides by 2. The 2's cancel. We get 1 equals, that all cancels. This is x to the negative 1/2. We need an x to the first. So to get rid of that negative 1/2 power, we need to raise this to whatever would make that a positive 1. So you say, what do I multiply negative 1/2 by to make it positive 1? You'd multiply it by negative 2. So you're raising both sides to the negative 2. So then out of there, we get 1 to the negative 2. Well, that's just 1 is equal to, those powers cancel out, and so we're left with x equals 1. That is the x value. That's what they refer to in our definition as the C value. And look, miracles of miracles, it lives between 0 and 4, which is where we said it had to. Be careful on these problems because sometimes they'll just want you to find where that x value is. Sometimes, as you're looking at on this one, they want the coordinates of the point. Coordinates of the point mean the x and the y. And so right now, all you have is the x value, and you need to find the y value that goes with it. Well, not a big deal. You go back to your original equation, plug in your x value, get out the y value. So plugging in 1 to the square root of 1 is 1. So this is our y value. So for this problem, the final answer would have needed to be the coordinate point 1, 1. So at that point, the instantaneous rate of change, the slope of that graph, is equal to the slope of the derivative. So if we put that into a picture, what we would see is that our right there, so if we're going between 0 and 4, the slope between those 2 points on the square root graph are going to be the same as the instantaneous rate of change at 1. So at that point, it's going to have the slope of those 2 lines are the same slope. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.